Welcome to LumberPro, where chainsaws scream, harvesters roar, and log trucks roll. Join us to explore raw machinery, wild forests, and the journey of timber from stump to sawmill. Power up, head to the woods with LumberPro. In the cool, lush forest, where sunlight streamed through the canopy like golden ribbons, the sudden wail of a chainsaw pierced the air, howling like a siren announcing the start of the workday. It was a sound that roused the creatures of the woods and signaled the beginning of a laborious day for the lumberjack. And from that moment, the journey of transformation for an ancient tree trunk began. The chainsaw roared in the silent ancient forest, its sharp scream slicing through the still air. The spinning blade sank deep into the trunk, bursting through thick bark as sawdust exploded like tiny fireworks. The wood groaned and cracked under invisible pressure, until the whole tree shuddered and crashed to the ground, shaking the earth with its weighty fall. In the midst of the still forest, the chainsaw ignited like a mechanical beast awakening. Its metallic scream echoed with each pulse, the blade spinning like a steel storm carving into timber. Sawdust floated in the filtered light beneath the canopy, tracing ghostly spirals through the once tranquil air. The roar of the chainsaw swept through the forest like an alien sound. Birds scattered in a flutter of panic, and leaves fell like rain before the ground trembled with the tree's collapse. As the tree fell, a patch of sky opened above, casting a harsh beam of sunlight across the forest floor, a new silence following the loss. The chainsaw lunged forward like a steel jaw, grinding through the tough layers of wood. Each rotation of the blade scorched a dark scar into the trunk, as if the forest were being bitten by an unnamed creature. Its relentless growl echoed like a prolonged groan from the heart of the wilderness.
say that was successful. Nice job, Logan.
As the blade completed its final circle, the trunk quivered slightly, swaying with a hesitant grace. Then suddenly, with a sharp, cracking snap, the entire tree tilted and fell to one side. In that instant, the air seemed to hold its breath, then erupted as the tree slammed into the ground. Dirt flew, birds scattered, and the once shaded grove was flooded with harsh, naked light. The trunk split and fell with a thunderous crash, halting the forest in a moment of stunned silence. Leaves drifted down like soft ash, and birds fell quiet. Where the tree once stood, only a hollow circle remained, blanketed in sawdust, a bare stump jutting upward. The ground sagged beneath the weight, not just of timber, but of memory. A chainsaw can cut through large tree trunks in a short amount of time, significantly reducing the harvesting duration compared to traditional manual methods such as axes or hand saws. With a chainsaw, workers don't need to exert as much physical effort, which reduces fatigue and increases daily productivity. Chainsaws can be used for various tasks, including felling trees, pruning branches, and milling wood on-site. They are effective on different wood types, from softwoods to hardwoods. The chainsaw blade enables accurate and straight cuts, minimizing wood loss due to incorrect cuts or splintering, thereby improving product quality. Designed to be compact and lightweight, Chainsaws can be easily carried and operated in dense forests, steep slopes, or narrow areas where heavy machinery cannot access. Although chainsaws can be hazardous if used incorrectly, proper operation and safety protocols help reduce accidents compared to handling bulky manual tools. The chainsaw's high-speed rotating blade can cause deep cuts, including loss of fingers, hands, or other body parts in case of accidents. Kickback hazard. This dangerous phenomenon occurs when the tip of the blade strikes a hard object or gets stuck, causing the saw to jerk back violently toward the operator, potentially causing serious injury. Logging often takes place in forests with rough, slippery terrain, increasing the risk of falls, collisions, or being struck by falling trees. Sawdust and small wood chips can enter the eyes, causing irritation, corneal scratches, or severe damage, potentially leading to vision loss if protective goggles are not worn. Sharp wood fragments can puncture or scratch the skin, causing minor injuries or irritation, especially at close range. Fine sawdust particles suspended in the air can irritate the respiratory tract, causing coughing, breathing difficulties, or lung diseases with prolonged exposure. In the midst of the dense forest, the bright yellow forestry machine stands out among the towering trees. Equipped with large crawler tracks and a sturdy frame, it moves easily over rugged terrain filled with roots and rocks. The air echoes with the roar of the engine, mingled with the sounds of startled forest birds scattering away. The cutting head, also known as the harvester head, gently grips the tree trunk using hydraulic steel arms. Within seconds, a spinning circular saw cleanly slices through the nearly 50 centimeters diameter base. The tree falls with a heavy cracking sound, and the ground trembles slightly under the weight of the collapsing trunk. After felling, the machine pulls the trunk through the cutting head. Spinning debarking knives quickly strip away the outer bark. Then, the automatic length measuring system determines precise cutting points. Another saw blade promptly extends and slices the log into evenly measured sections. A modern harvester can fell and process between 40 to 60 trees per hour, vastly surpassing manual labor productivity. With GPS positioning and intelligent control systems, logging becomes more precise and results in less timber waste. Modern forestry machines are equipped with length and diameter measurement systems and software that optimize log segmentation. As a result, each cut is technically precise, minimizing material waste and maximizing the economic value of the harvested wood. Using machinery reduces the risks faced by workers in dense and hazardous forest environments. The operator remains safely inside a sealed cabin, protected from falling trees, saw blades, and venomous insects. This significantly lowers the chances of serious workplace accidents. Harvesters can operate efficiently even in wet, muddy, or freezing conditions. Their crawler track design and powerful hydraulic systems allow them to access and function in terrain that would be challenging or dangerous for manual workers. Tree cutting machines use high-speed saw blades and powerful hydraulic systems, which can cause severe accidents if mechanical failure or operator error occurs. Common accidents include hand entrapment in moving parts, flying broken blades, or high-pressure hydraulic fluid leaks. Tree felling always carries the risk of the tree falling unpredictably, especially in strong winds or when the tree is internally rotten. Even with a protective cabin, nearby workers or equipment can be seriously injured by an unexpected tree fall. Harvesters operate on rough forest terrain, which may include landslides, streams, roots, and large rocks. Improper handling can cause the machine to skid, tip over, or get stuck, leading to equipment damage and endangering the operator. Logging trucks are essential vehicles in the timber harvesting industry, responsible for transporting harvested logs from the forest to collection points or processing plants. These trucks usually have a sturdy build, large cargo beds, and specialized log securing systems to ensure safety during transit. Their large carrying capacity enhances harvesting efficiency by reducing the number of trips. In forest environments, logging trucks must navigate dirt roads, rugged trails, and sometimes very narrow paths. Drivers need professional skills to handle these complex terrains, avoiding vehicle damage and protecting the cargo. Trucks are often equipped with sturdy suspension systems and specialized tires to traverse mud, gravel, or slippery sections. Logging trucks play a vital connecting role in the forestry supply chain, transporting timber from harvesting sites to processing plants or storage areas. Efficient transportation helps maintain a stable supply, reduces costs and waiting times. This contributes to increasing the value of wood products and promotes sustainable economic development. On winding forest roads, a logging truck loaded with tree trunks quietly makes its way to the collection point. The steady engine hum mixes with the sound of tires crushing dirt, rocks, and mud under the heavy load. Under sunlight filtering through the canopy, the truck stands as a symbol of strength and durability, playing a crucial role in the entire timber harvesting and transportation process. The damp red clay slope looms ahead like a vertical wall. The heavily loaded logging truck, stacked with long, thick trunks, growls as if summoning strength. Its tires spin slowly, clawing at the earth, flinging mud behind them. The engine roars in the thick forest air, each meter of ascent a battle between steel and brutal terrain. Climbing with a heavy load demands a powerful engine, properly geared transmission, and reliable braking and cooling systems. The driver must skillfully balance throttle and gears to prevent wheel slippage or stalling mid-slope. Even a small mistake can result in the truck sliding backward or tipping, posing serious danger. When the slope becomes too steep and the load too heavy, the logging truck can no longer climb. The logging truck and the pusher vehicle must be flawless. If the tow pulls too hard or the pusher exerts too much force, it can cause loss of balance, tire slippage, and cargo security. The tree stump removal excavator is a type of heavy machinery equipped with a specialized claw or stump puller designed to uproot trees and stumps from the ground. This machine is commonly used in land clearing, site preparation, and post-logging cleanup. Excavators used for stump removal are often fitted with specialized attachments such as grapple buckets to grip and pull the stump, stump rippers with sharp teeth to pierce and cut through roots, stump grinder heads that crush and grind the stump in place. The machine operates using the powerful hydraulic force of the boom arm. The operator maneuvers the arm to dig deep into the ground, clamp onto the stump, and then lift and yank it out. In some cases, roots may need to be cut first with a hydraulic blade attachment. Saves time and labor compared to manual stump removal. Capable of handling large and old stumps. Can combine stump pulling and grinding on-site for quick disposal. Causes significant soil disturbance, affecting soil structure, generates loud noise, potentially disturbing nearby areas, can be hazardous if not operated correctly, posing risks to both operator and machinery. A stump grinder is a specialized machine used to grind down or shred tree stumps left after a tree has been cut down, instead of uprooting the entire root system. It works by spinning a cutting disc or wheel with hardened steel teeth that chip away the stump into mulch. The stump grinder typically consists of the following components: grinding disc or wheel with cutting teeth, engine powered by gasoline, diesel, or electricity, control handles for maneuvering and precision operation, chassis with wheels or tracks. Some models are excavator mounted. The machine operates by lowering the spinning grinding disc onto the surface of the stump. The cutting teeth scrape, carve, and chip away layers of wood until the stump is reduced to mulch or ground below soil level. Causes less soil disturbance compared to stump pole. Fast, neat, and effective for small to medium-sized stumps. Easier to control, ideal for urban areas or residential yards. The log splitter stands tall in the lumber yard, like a cold-blooded machine from a mechanical world. Each time a log is placed on its bed, the V-shaped steel wedge slowly descends, pressing forcefully into the timber. A heavy cracking sound echoes as the trunk splits into two, then four parts. Wood fibers peel apart along the grain, releasing the deep, earthy scent of the forest. The log splitter operates via a powerful hydraulic system, generating pressure up to several tons. When the lever is engaged, the hydraulic piston pushes the splitting wedge into the log with immense force. Depending on the wood type, soft like acacia or hard like ironwood, the pressure and duration are adjusted accordingly. Some modern machines can split logs automatically in multiple directions at once. The crack of splitting wood echoes sharply, like the sound of bones snapping in silence. Each split stretches and vibrates the wood under the weight of steel. Sawdust and tiny chips float in the air, catching light that highlights the silky grain. Watching the timber split smoothly and symmetrically brings a strange satisfaction, like mastering nature by precision. The log splitter plays a crucial role in the post-harvest processing phase. It reduces large tree trunks into smaller segments suitable for trucks, kilns, or further processing like sawing and drying. Thanks to the splitter, what used to be a heavy and dangerous manual task is now faster, safer, and more consistent. Manual log splitters use human force or simple engines, suitable for households or small workshops. Their advantages include low cost and easy maintenance, but they offer lower productivity and higher injury risk. In contrast, modern automatic splitters feature safety sensors, high efficiency, adjustable splitting force, and multi-directional splitting, ideal for industrial scale operations. Log splitters maximize forest resource use by reducing substandard logs into firewood, sawdust, biomass pellets, or paper pulp. This significantly reduces wood waste, lessens the need for new tree felling, and promotes a circular economy in the forestry sector. Log splitters generate loud noise when splitting large or dense logs, averaging between 85 to 100 decibels, similar to a train. This affects hearing and can cause fatigue over time. Therefore, they should be installed in soundproofed areas, or operators should wear noise-canceling earmuffs to maintain occupational health. A wood chipper is an industrial machine specialized for timber harvesting and processing. It is designed to shred tree trunks and branches into uniform wood chips or small fragments. Equipped with a powerful engine and sharp blades spinning at high speed, the machine can handle large volumes of wood in a short time, saving labor and boosting production efficiency. The chassis is usually made of sturdy steel, capable of withstanding strong impacts during operation. During operation, tree trunks or branches are fed into the chipper's intake chute. The rotating blades rapidly crush the coarse wood into tiny fragments. The machine roars loudly, accompanied by the sound of wood chips scattering outward. The resulting wood chips can be used as raw material for paper production, biofuel, or eco-friendly building materials. The wood chipper plays a crucial role in processing wood byproducts, transforming and used trunks and branches into valuable raw materials. Compared to manual methods, the chipper saves time, minimizes waste, and improves economic efficiency. Additionally, processing byproducts with the chipper helps reduce negative environmental impacts by preventing leftover wood from accumulating and increasing wildfire risks. Amid the vast forest space, the wood chipper stands as a powerful machine. Tree trunks are fed into the chute, and wood chips fly out like a gentle rain, mingling with the fresh scent of timber. The roar of the engine drowns out the birdsong, creating a scene that is both industrial and wild. The chipper aids efficient harvesting while maintaining ecological balance by maximizing resource utilization. Chippers shred and use tree trunks and branches into valuable wood chips, minimizing waste and maximizing resource utilization. Compared to manual methods, chippers operate quickly and continuously, greatly reducing labor effort and harvesting time. Smaller wood chips are easier and cheaper to transport and store than large tree trunks. Wood chips can be used in various industries such as paper production, biomass energy, construction fillers, or ground cover materials. Efficient processing of wood residues reduces wildfire risks caused by accumulated debris and promotes sustainable reuse of wood waste. Blades or shredding drums rotate at very high speeds and can cause severe injuries if operators are careless or come into direct contact. Small wood chips are ejected forcefully and can injure eyes or other body parts without proper protective gear. If the wood fed into the machine is too large or jams inside, it can cause machine malfunction or sudden dangerous reactions. Wood chippers produce loud noise and strong vibrations, which can damage hearing and cause operator fatigue without proper protection. Lack of experience, ignoring safety procedures, or working while fatigued can lead to serious accidents. From the deep forest to the rolling machines, timber harvesting is where man, nature, and technology meet. Thanks for watching. See you on the next journey, where wood is not just material, but a story. Don't forget to like, subscribe, and stay tuned for more exciting videos.